To sustain life, complex organisms must transport nutrients and waste to and from the body's living cells. In most animals, the transport medium is blood, flowing through the intricate internal network we call the circulatory system. We often ignore the critical functions of this river of life until something interrupts the flow. A punctured vessel, a loss of blood, a spasm of the heart, and the situation suddenly becomes one of life or death.
We're in your area. We were called to the residence of a 59-year-old male. Mild distress at this time. Coming with some shortness of breath without any chest pain.
Dr. Barry Heller routinely faces life or death struggles. In the emergency room, any severe injury can take a life. The danger depends on which system is damaged.
Okay. No chest pain, just shortness of breath, really.
If I were to try to prioritize or put in order which would be the most life-threatening injuries, I think I would have to say that for immediate life threat, injury to the cardiovascular system, particularly to the heart or to the major vessels, would be the most quickly fatal problem that you could suffer.
Surviving a trauma often depends on a quick damage assessment of the body's cardiovascular system.
This machine here is going to take your blood pressure. Okay.
The heart, blood vessels, and blood form a support network so vital that its interruption for more than a few minutes results in death.
Let's just wrap this on your finger for a minute.
The primary threat lies in cutting off the body's main source of oxygen.
One of the primary functions of the circulatory system is providing oxygen to the tissues. Blood is sent to the lungs, and with the very fine membranes in the capillaries of the lungs, oxygen is taken in, the blood absorbs the oxygen, and then is taken to the other parts of the body where it dumps off the oxygen, and the blood cells then pick up the waste products, the carbon dioxide, and they take it back to the heart and eventually to the lungs again.
I want you to just keep it on for now. I know it feels like you do better without it, but you really do better with it, okay?
In a trauma situation, we worry particularly about certain tissues not getting the oxygen, in particular the brain. A lack of oxygen for a certain amount of time, maybe 4 or 5 minutes, can certainly cause brain damage.
He has had heart trouble before, he's had an angio before.
Given its crucial role in sustaining life, the structure and function of the cardiovascular system is surprisingly simple.
The components of the circulatory system are the heart, which is basically the pumping mechanism. It's a bit larger than your fist. It's an amazing little muscle. It pumps maybe 1,250 gallons of blood a day. Then you have the blood vessels that distribute all the blood to the tissues, and there's estimated to be as long as 60,000 miles of blood vessels in a human body, which is quite an amazing thought. And then finally we have the blood.
All three parts of the circulatory system must work together to keep the blood in constant motion. The action begins at the system's pump.
The driving force for blood to flow is the pumping action of the heart. It generates a very high pressure at the origin and then forces the blood to the outer edges of the system. After the blood reaches the tissues through the capillaries, it is picked up by veins, and the veins then carry the blood back to the heart. They're a much thinner walled, much lower pressure system than the artery side.
In the circulatory system, blood travels from high-pressure arteries to low-pressure veins. Arteries are composed in layers of muscle and elastic tissue, which deliver blood at high pressure. In the smaller arterioles, pressure drops considerably until the blood enters the capillaries. Here, pressure must remain low for the exchange of nutrients and waste.
The capillary is the very smallest blood vessel in the body. They are small enough to let just a single blood cell through. In fact, if you were to put 10 or so capillaries together, it would still be thinner than a human hair. So it's an amazingly fine structure, and the wall of the capillary is very, very thin, which is what allows the nutrients from the blood cells to pass then into the tissues.
After the capillaries, venules and veins return the same volume of blood, but spread out in more vessels that stretch to keep pressure low. To help this low-pressure side pump blood against gravity, veins contain small valves that prevent backflow. In addition, muscles squeeze against vein walls, pushing blood back to the heart, which once again pressurizes the arteries.
As the driving force of circulation, blood pressure is crucial to our survival.
Chief complaint, gunshot wound, left chest, no breath sounds to the affected side, it's hypotensive, 80/40.
In a trauma situation, if we were to notice low blood pressure, we would consider that a very critical situation. There is some tissue that's not getting the nutrients and oxygen that it needs.
To maintain blood pressure, all three components of the circulatory system have a crucial role to play.
The role of the heart in regulating blood pressure is, number one, the heart rate, and number two, how strong the heart is pumping. The harder the heart is pumping, obviously the higher the blood pressure will be, and in addition, the faster the heart is pumping will also raise the blood pressure.
Where is that blood? Call the blood bank, please. We need
The role of the blood vessels in blood pressure is basically related to the distensibility or the elasticity of the walls of the artery. If you were to dilate the blood vessel, you would expect the blood pressure to be lower. If you were to contract it, you would expect the blood pressure to be higher.
We need an x-ray. Bring in the plate, please.
But in order for the heart to pump and the vessels to regulate, there first must be enough fluid in the system.
Okay, get the plate under. Get the plate under.
The total circulating blood volume is very important to blood pressure.
Blood pressure is still only 80.
In the emergency department, for example, if we see somebody with a low blood pressure, I think it's the first thing that we usually think of is this patient losing their blood volume somewhere? You know, are they dehydrated because they haven't had enough fluids? Are they bleeding inside somewhere? And that's why their blood pressure is low. So once your blood volume drops down, one of the first things you see is the blood pressure to go down. In addition, you also see the heart rate go up to try to compensate for that.
Blood bank, this is the ER. We need 2 units of O negative stat.
The body's ability to adjust to extreme situations is a source of constant wonder. Without it, many patients would not survive to reach the emergency room.
Okay, clear for x-ray.
The body is a pretty amazing organism because it can adjust itself to various insults. And for example, if a patient were to lose a lot of blood, how would the body respond? The body would respond mainly by activating what we call the sympathetic nervous system. This causes a release of adrenaline into the body. This adrenaline has several functions. It, number one, causes the heart rate to go up. This helps to maintain the blood pressure and the blood flow. It also causes the arteries to constrict, to help the blood pressure to go up. It also helps to shunt the blood to the areas that are most needed, the brain, the muscles, and the heart. And it takes it away from the skin, from the digestive organs, which are not needed in a time of crisis.
Is the OR ready?
The OR's ready.
All right, let's pack them up.
In an emergency, the body can adjust all three parts of the circulatory system: the heart, the vessels, and the blood that circulates. However, when the injury is severe, the system needs help restoring its internal balance.
I think our main function, or our main thrust in the emergency department, is to reestablish homeostasis in patients who have lost it. And when we talk about homeostasis, we're talking about an equilibrium between various dynamic systems in the body. And when we see patients that are out of equilibrium, we need to find out why. We have to find out what it is that's out of balance, and then what do we need to do to get it back into balance.
How long ago did this happen? Okay.
On land or underwater, all complex animals pump blood through a circulatory system. But nature has designed different systems to meet the demands of different environments. These adaptations often begin with the animal's oxygen requirements and the gas-carrying protein inside red blood cells called hemoglobin.
The ability of the hemoglobin to bind oxygen varies between different organisms and may be a function of the oxygen levels that they are normally exposed to in their environment. Let's say you're a fish living in a river which has a very low oxygen environment. You may have a hemoglobin that has a very high affinity for oxygen.
Dr. James Hicks studies the circulation of many different animals, but his favorite are reptiles. Their adaptations also begin with blood.
The components of reptilian blood are the same as the components of mammalian blood, but there are some differences. For example, they are said to be nucleated red blood cells. That is, they have a nucleus and they can carry out protein synthesis.
This differs from human red blood cells, which don't have a nucleus. The reptile's nucleated blood cells allow the animal to produce more hemoglobin protein, even after the cells begin to circulate. This may give reptiles a competitive advantage in their environment.
Say you were a turtle and you were burying or burrowing into the bottom of a pond for the winter, where there was so little oxygen you could not measure it. In those animals, an interesting potential function of these nucleated red cells might be to synthesize hemoglobins which have a very high affinity for oxygen, so they can grab any oxygen that's out there and circulate it out to the rest of the body.
Reptiles can survive in these low oxygen environments because their slower metabolism requires less oxygen.
If we look at the metabolism of a 6-foot alligator and compare it to the metabolism of a 6-foot man, we will find that under resting conditions, the alligator has a metabolism that is 5 to 10 times lower than it is in the 6-foot man. So there is this basic difference between reptiles and mammals in their overall metabolic rates.
Reptiles and other vertebrates show different adaptations related to oxygen delivery. We can see these unique features in the heart structures of each organism, including the complex design of the human heart.
The human heart represents 2 pumps in one. The right heart pumps blood to the lungs through the pulmonary circuit. The left heart pumps blood to the body through the systemic circuit. Each side has a filling chamber called an atrium and a pumping chamber called a ventricle. From the body, blood enters the right atrium, then the right ventricle, which pumps it into the pulmonary artery on its way to the lungs. Flaps of tissue called valves prevent backflow and keep blood flowing in the right direction. From the lungs, freshly oxygenated blood returns through pulmonary veins to the left atrium, then the left ventricle, which pumps it out the main artery to the body called the aorta. This durable 4-chambered muscle beats some 2.5 billion times during the average human lifespan.
Only animals with exceptionally high oxygen requirements, such as mammals and birds, use a 4-chambered heart. Fishes have a 2-chambered heart with 1 atrium and 1 ventricle. Reptiles and amphibians have a 3-chambered heart with 2 atria and only 1 ventricle. In reptiles, the single ventricle is partially separated into a right and left side, which offers these animals the unique ability to direct their blood flow.
Unlike mammals that have to send all their blood right to the lung, reptiles can actually bypass the lung and send the blood right back out to the body, or it can recirculate right to the lung again. Reptiles have the capacity to actually bypass either the pulmonary or systemic circulation.
In his laboratory, Dr. Hicks studies alligators which have a special feature not found in most reptiles, a heart with 2 aortas. He hopes to discover exactly how the alligator uses this extraordinary adaptation.
What we're trying to understand is what went on to result in this kind of circulatory design. It just doesn't seem to make sense when you look at it. Why have the second aorta? What kind of functional significance, if any, does this provide to the animal?
Much like the shared ventricle common to most other reptiles, the alligator's second aorta and other adaptations may provide a shunt that can bypass either the lungs or the body. Dr. Hicks believes this may help the animal alter blood flow for strenuous activities that require more oxygen.
These shunts may be involved in the prolonged dives. For example, alligators can stay underwater for hours at a time. They don't survive in spite of the shunt. They really may be surviving because of the shunt, and we're trying to understand how the shunt may be helping them survive and be a successful vertebrate.
Whether it's 2 aortas, high-performance hemoglobin, or a 4-chambered heart, different animals meet the challenges of circulation in different ways, depending on the unique environment in which they live. By delivering critical nutrients to the body, the circulatory system fuels the processes of life. Because it requires so little attention, we forget just how vital the system is, until something goes wrong.
I woke up 3:30 in the morning and I was just sick. I was really just felt sick. I can't describe it to you. But within a minute and a half, it became clear to me. I was having chest pains. I was getting pain in my left jaw. I was very nauseous, and I was real clammy, sweaty, clammy. I knew I was having a heart attack.
Jerry had a close call, but he's not out of danger. Cardiovascular disease is the leading cause of death in the United States. A heart attack presents the greatest danger because it interferes with the heart's normal pumping action.
In cardiac function, we talk about 2 parts of the cardiac cycle, systole and diastole. In systole, the pumping chambers, the ventricles, push blood into the arteries, and in diastole, the ventricle or the pumping chamber relaxes and allows it to fill. The 2 atria beat at the same time. Then after a pause, the 2 ventricles beat. The reason for that is that when the atria have contracted or had a beat, you have to allow a little time for the ventricle to fill. First the atrium, then the ventricle. This helps in a way to keep the blood flowing in the right direction in both sides of the heart. And if it functions in an orderly manner, it helps to keep the output or the amount of blood pumped by each side of the heart equal. The 2 sides of the heart are pumping blood to different parts of the body.
But a sudden disruption in blood flow to the heart can upset this cardiac cycle.
I first met Jerry when he presented with an acute heart attack. What happened was that one of the three arteries, the main three arteries that feed the heart muscle, developed a small blood clot which formed in the artery that feeds the heart muscle. And when that began, that area of heart muscle no longer had the blood flow that it needed to carry on active metabolism and keep beating. So that area began, in a sense, to die. And this is the beginning of a heart attack.
And how's your cholesterol been running?
Pretty good.
To prevent a dangerous relapse, Jerry's doctors carefully monitor him for signs of a blocked artery. A heart attack often weakens one chamber of the heart, producing an unequal balance of blood flow.
You're still warming up here. Your heart rate's up to 90. You've been going a little over 2
I had some shortness of breath while this was going on, and I'm not sure that was anxiety instigated or what the reason was.
The left side of the heart was pumping less blood than the right side of the heart. The blood pumped from the right side of the heart into the lungs would be trapped in the lungs. It would not be escaping out. So you would have more blood in the lungs.
A weakened pump is only one problem facing a heart attack victim. Even more common is the disruption of the pumping rhythm, normally maintained by the heart's own pacemaker.
The heart's normal beating rhythm is orchestrated by a natural pacemaker located in the wall of the right atrium. This small patch of muscle, called the SA node, spontaneously generates an electrical impulse that spreads over both atria, causing them to contract. As the impulse spreads, it triggers the AV node, which delays, then relays the signal to both ventricles. Even without input from the nervous system, our hearts will continue to beat to the rhythm of this natural pacemaker.
So we'll start to put you to a little work
Assuming
here.
Jerry's heart gets a good supply of blood, it will beat normally. But if blood flow is interrupted, an abnormal rate or rhythm can result.
Patients that present with heart attack are subject to develop arrhythmias, which are abnormalities of the heart rhythm. The most common type of arrhythmia would be PVCs, or premature ventricular beats, which would be signs of irritability of the heart muscle because it's being starved from the blood flow. Abnormal rhythms are the major cause for sudden death when individuals develop a heart attack. Jerry did have a very slow heart rate, which was related to inadequate blood flow to part of the electrical tissue in his heart, such that the heartbeat actually slowed down. Jerry was fortunate in that he presented to the hospital quickly and thereby limited the amount of damage to his heart muscle.
I was a little surprised that I had a heart attack, although I don't know why I would be surprised. Both of my parents died of heart disease. I should have known, but nobody believes it's going to happen to them.
About 90% of the important information that we needed to diagnose his condition as an acute heart attack came from the history. That here's an individual with a strong family history of coronary artery disease who has elevated cholesterol, who suddenly develops severe pain in the chest, jaw, and left arm. And in that individual, we would assume that he's having a heart attack until proved otherwise.
If any symptoms return during the examination, Jerry's doctors may use the surgical procedure which reopened his blocked artery after the first heart attack.
He underwent an angioplasty, which is a procedure where a very small balloon is put across the narrowed area of the artery and pushed through the blood clot, and then the balloon is blown up to create a larger channel for blood to flow through, thereby interrupting the process of a heart attack.
Stand nice and still. We're recording your...
To confirm the artery remains open, Jerry makes regular visits to his doctors. But the most important thing he's doing to avoid another heart attack is changing his lifestyle.
My life has changed in In various ways. I'm eating very differently, I'm exercising very differently, and I think I'm dealing with the stresses of life very, very differently.
I think the outlook for Jerry is very bright because of the changes which he has been able to achieve with diet, exercise, and medication to reduce his blood cholesterol.
It was definitely a wake-up call, and I guess I was pretty lucky.
Only time will tell if Jerry has found the key to his heart troubles. While it sometimes fails, the cardiovascular system normally performs with remarkable resilience. This intricate internal network operates without pause, transporting nutrients and waste to and from our living cells. To our bodies, the circulatory system is a river of life, rich with the essential chemicals we need to survive.